All right, ladies and gentlemen, this is video number 2 of Odysseyware. We're still talking about that first characteristics of waves lesson. This is if you needed a little bit of help getting through some of those last questions. And we're going to really focus on the questions for this video. Okay, so let's get to some examples. We're going to actually walk through these examples together. The first example here is a bunch of questions that talk about waves passing under a dock. All right, and for all of these questions, what I think is super helpful is to start by drawing out a picture and writing out the information that we know. All right, so let me get myself some space on my whiteboard and we will do exactly that. All right, so I'm gonna diagram this problem. We've got a dock, right? Just in case you don't know what a dock is. It's the thing that you tie your boat up to, usually made out of wood. And we've got some waves passing by in the water. All right, cool. And then it gives us some information about those waves. And the information that it tells us is, first of all, it says the wave crests are 8 meters apart. Now, if I've watched the video before, I know that the crest is the top of the wave. And so I'm just gonna do this. And I'm gonna label that as being 8 meters apart. The other thing that it tells me is the time for a wave to pass by is 4 seconds. Okay, I can't really add that to my picture, or at least I can figure out how, so I'm just gonna write it out. It also has markings on this post. Okay, submerged in the water, indicate the water level fluctuates from a trough. So the trough is at 6 meters, and the crest up here is at 9 meters, okay? And now it's gonna ask us a bunch of questions about this, all with the same setup. So like question 6, question 7, question 8, question 9, all of the same setup. And then it does the same thing, or sorry, question 10, then it does the same thing with questions 11, 12, 13, 14. It gives you another picture and it asks you a bunch of questions about it. All right, so we wanna make sure we can answer questions like that, and drawing a picture is a really good way, especially when you've got kind of a weird question. We draw pictures in physics all the time. All right, so the first question that it asks us is, what is the amplitude? And so in order to answer questions like what is the amplitude, there's gonna be 2 main resources that we're gonna draw on, all right? Resource number 1 is gonna be this equation, okay? This equation is gonna allow us to do some calculations. If we're given wave speed, frequency, or wavelength, we can use this equation. If we're asked for wave speed, frequency, or wavelength, we can use this equation. However, another resource that we're going to use is the fact that we know that period, right, the number of seconds per wave is going to be inverse of frequency, which is the number of waves per second measured in hertz. So we have this equation, and we have this statement that period and frequency are inverse. The only other resource we have is knowledge of vocab terms that describe a wave. So some words that describe a wave are amplitude. Amplitude is the height from the middle of the wave, which is called equilibrium, up to the crest. So that's going to be this height is the amplitude. Okay. The other measurement we have to pay attention to is the wavelength, which is the distance from one crest to another crest, or it could be the distance from a trough to a trough, or it could be the distance from equilibrium going up to a crest to equilibrium going up to a crest, whatever. There's a lot of ways to measure this, but they're all gonna give you the same number. I'm just gonna focus on crest to crest. That is wavelength. Okay, so we've got 3 resources: our knowledge of waves, and their vocab, the fact that period and frequency are inverse of each other, and this equation. So in this first part, I'm looking at my question, my picture over here, and it is asking me what is the amplitude. So to be able to answer that, I need to look at my picture. Well, I know that amplitude is the distance from the middle of the wave up to the top. I have some information about the height of the wave here. I know that at the bottom of the wave, it's 6 meters, top is 9. If I'm trying to answer this really quickly, the answer that I'm gonna give is, oh, well, that's 3 meters, because I'm going from 6 up to 9. But that's not how we measure amplitude. We actually go from halfway up to the top. So we're gonna cut that 3 meters in half, and our amplitude is gonna be 1.5 meters, okay? When we look at the next question, it's asking us, what is the wavelength of the wave? Well, it actually told us, if we paid careful attention, it actually told us the distance between crests was 8 meters. And so I know that that's what wavelength means. So I'm gonna go ahead and plug in 8 meters as my answer there. All right, what about the period of the wave is the next question. Period of the wave asks us how many seconds per wave, right? Remember, period is measured in seconds. And in fact, it says in the problem, waves pass in 4 seconds. So bam, it gave us the period right there. It told us the answer. And then it's gonna ask us for the frequency. All right, so I'm looking at what I was given in the problem. It does not tell me the frequency. It never says number of hertz. So I can either use this equation or I can use this resource. And you'll notice I'm gonna use this one. So I know period is the inverse of frequency, okay? So what that means is if my period was 4 seconds, which it was, then I'm going to do the inverse of that, which means just 1/4 is my number of hertz. Now, I don't think in the problem it gives it to you as 1/4. It doesn't give it to you as a fraction because usually in science we use decimals. So it's not going to give you 1/4, it's going to give you 0.25 as your correct answer. All right, so notice this is how we're doing it. We're drawing a picture because it helps us understand. We're knowing all of our vocab. We're also using the idea that period and frequency are inverse. Do we have to perform a calculation? Well, yeah, we do, because the next one is asking us calculate, it even says calculate, so that's your hint, right? Calculate the velocity of the wave, okay? If it says calculate, you're gonna have to use an equation. So we've got to look at our equation. We want to find velocity, okay? To find velocity, we need these other things. I need frequency and I need wavelength, okay? Well, we just solved for the wavelength a second ago, okay? So we know it's gonna be 0.25 hertz because we did the inverse of the period to find the frequency. Remember, that was just a second ago. If you don't understand where this 0.25 came from, back up. Wavelength, we were given in the problem also. We know the wavelength is 8 meters. Okay, so once I have this, sorry, I shouldn't probably should not have written that unit there. Just makes it more confusing. So we've got 0.25 times 8 is the wave speed. So all I gotta do is plug that in, and I'm gonna get a wave speed of, well, something. You can plug stuff into your calculator. But you're gonna go ahead and multiply those things together. So this is how we do these problems, is we're using the idea that frequency and period are opposites, inverse. We're using this vocab of amplitude and wavelength. We're also using this equation when we need to calculate for something. All right, you've got a bunch more problems to answer, but at least that's some help on the first 4. Good luck.